Okay, here's what you have to know when you're graphing polynomials. You have to know, first of all, the end behavior. And you have to know the zeros of the graph, or the x-intercepts. So where it's crossing the x-axis, so we're going to have to factor some to solve for x. We also need to know about the special zeros. So there's some that are going to be special zeros when we do this. Billy, put your phone away. Okay, so we're going to start with this first one as the bell ringer, or the bell ringer is going to be our first example. So we already said the end behavior for this one. If I said f of x equals negative 2x to the fourth plus 2x squared, we already said that the end behavior is going to be not up, up, down, down, because of this negative even, right? So we know it's going to be down, down. The second thing you need to do is find the zeros. So think back to the last chapter. When we have to find zeros of something, what do you make zero? The y. So we're looking for the x-intercept. So the y here is this f of x. So I have 0 equals negative 2x to the fourth plus 2x squared. So this is not the x method. There's only two terms. So when we have two terms, we always look to see what they have in common. So what do those two have in common? Okay, they have a 2 and they have x squared. So I'm going to take out a negative because the first one's negative. So I'm going to take out a negative 2x squared, which is going to leave me with x squared in the first term. And then what do I get when I factor out a negative 2x squared in the second? Negative 1. Yep. Okay. Now, does that on the inside look familiar? Yeah. It's one of those difference of two squares, because I have two perfect squares in the subtraction. So this can factor now to x plus 1, x minus 1. And after I get it totally factored, what do you do with each factor? Put one equal to, each one equal to 0. Okay? So I'm going to have negative 2x squared equals 0. I have x plus 1 equals 0. And x minus 1 equals 0. So I'm finding my x-intercepts. Let's start with these bottom two because they're the easy ones. This is a special one. So here I subtract my 1 over. So my first 0 I have is x equals negative 1. Then I have x equals 1. And this one, I divide by negative 2, so I get x squared equals 0. So if x squared equals 0, what I want you to think of is there's two x's that equal 0. This has a multiplicity of 2. So x equals 0 with a multiplicity, you can just put mult of 2. This is a special 0. I'll tell you what it is in just a minute. So we know our graph. We know our graph is going to touch the x-axis when x equals 0, when x equals 1, and when x equals negative 1. We also know our end behavior. What was our end behavior? Down, down. So I know on this end it's going to go down, and I know on this end it's going to go down. We're not going to be exact with our graphs, but we know it's going to go down. So this graph here, the multiplicity of 2, I want you to put a note on the side here. When you have a multiplicity of 2, I want you to write the word bounce. So what that means is when you have x-intercepts, you either go through the x-axis, like draw your line through it and it goes through the point, or it just touches the point. When you have a multiplicity of 2, wherever you have a multiplicity of 2 at those zeros, it just is going to bounce. So it's going to look something like this. Bounce over. Looks like an M, kind of. This was our special 0. Every other 0 that you get, it's just going to go through the point. So it's going to touch at that point. This one's going to bounce off, go back up, and go through at the other point. Our graphs don't have to look exactly the same. The things that have to look the same are end behavior, our zeros, and the special zeros, where it's bouncing. That needs to look the same. Otherwise, yours might go all the way up, bounce down, all the way back down. It's okay. Okay? So we're going to do another one. And I think the next one doesn't have, well, it might. I can't remember. Only if it has multiplicity of 2. It's special than that. You probably won't have any higher than that. Well, if you have 3, it's the same. It just goes through. Just worry about if you have a multiplicity of 2. Then you have a multiplicity of 1. All you have to worry about is multiplicity of 2 for today. Okay, so let's do another one. Oh, this one does have multiplicity. Oh, it's going to be of 3, so it's not going to be as fun. Okay, so let's do this one. F of x equals 3x to the 4th minus 4x to the 3rd. I want to see one thing before we do this problem. Okay, why don't you write in what the end behavior is going to be. I want to see if I change one thing. No, we won't do it. Okay, so what is our end behavior going to be for this graph? Up, up. So our end behavior is up, up because we have a even positive. Okay? Now we need to find our zeros. So I have 0 equals 3x to the 4th minus 4x to the 3rd. What can I take out of there? X to the 3rd. So I have 3x minus 4. And I have x to the 3rd equals 0. And 3x minus 4 equals 0. So x to the 3rd equals 0 is x equals 0 with a multiplicity of 3. But I told you don't have to worry about multiplicities of 3. Those just still go through. Okay? And then this one I have to add my 4 over. So I have 3x equals 4. So x equals 4/3, or 1 1/3. So here are my zeros.
So
I just solved for
write multiplicity of 3.
Well, you probably should write multiplicity of 3, but it's not going to change your graph.
So, wait, where'd you get the, I know you have the x, you said the x cubed is 0.
Yeah.
But then why is there another x equals 0?
Because that's what that equals
Oh,
when you cube root it. So I've got just 2 places that it's going to touch the x-axis. I don't have any bounces because I don't have any x to the seconds. I'm going to see if you have x to the 4ths coming up, but I don't think you do. So I have x equals 0, and then we said this is 1 1/3, so I'm going to say it's about right here. Doesn't have to be exact. Our end behavior was up, up. So this graph goes like that. Now that's not the exact graph, but that's exact for what we're going to do today. The multiplicity of 3 gives it somewhat of an inflection point if you typed it in your calculator, but we're not going to worry about that today. We may touch on that later this week. So that's all you need to know for that.
like it would be 4 over 3. How do you where do you graph?
1 1/3. 1.3. 3, 3, 3, 3. Repeating. Okay, let me see what my next one is. Oh, we're not going to do that one. We don't need to waste time on that. Okay, we're going to do one more. I'm going to have you guys do this one on your own. It's out of the book, number 75. So, I'm going to see why I had that other one, because there was a real easy one. You don't need to do the easy ones. F of x equals negative 5x squared minus x cubed. First thing I would do is write this in standard form. So I would rewrite this as negative x cubed minus 5x squared. What's our end behavior going to be for this one?
Up, down.
Up, down. Okay, you guys finish this as best you can. Let's see what happens with the other one. Oh. Okay, so I found two zeros. I found x equals 0, but that had a multiplicity of 2. There's 2 of them. And I got x equals negative 5. Do you guys agree with me?
Yeah.
Okay, so I'm going to go ahead and plot those points. I have 0 and I have negative 5. We said it was up and down. So we know this is going up here and this is going down here. And then this is a good example of how you know there's a bounce, because I need to go from up here to down here, and I don't have another point to go through to make it loop down. So I know that at some point it's going to bounce, which is going to be at 0 is the bounce. So that means this is going to go through, because there's no multiplicity here, so that one goes through the x-intercept, and then we'll loop back up, hit 0, and bounce back down. That's a weird looking graph.
How did you know to go under?
Because that's just a normal point. So when it's a normal point, you just go through it.
Okay.
When it has a multiplicity, you're going
How
to
do you
touch
know
it and go back down.
and not up?
Because that would be a bounce. If you went up, you'd be bouncing at negative 5. We don't want it, we can't bounce here. That's not a multiplicity of 2. So we have to go through this one to go down here. And this is the multiplicity of 2.
And that's where it bounces.
So that has to be your bounce.
Oh, okay.
Maybe you start with the bounce. Maybe that'll help you. Bounce it down. Bounce around the room. Okay. There's one more I just want to show you real quick. If I have f of x, and you don't have to write this one down, f of x equals x squared plus 10x plus 25. This is going to be up, up. My zeros are going to end up, I'm going to have to do the x method here. And when I do the x method, I'm looking for two numbers that multiply to give me 25 but add to give me 10. What are those two numbers? 5 and 5. This is when you can do the shortcut. So you have x plus 5 and x plus 5. So here I have x equals negative 5, but what's my multiplicity? How many negative 5s do you have?
2.
2. So that's going to be a bounce at negative 5. So when I go to graph this, I only have one x-intercept, and it's up, up, which means this is a parabola that just touches the x-axis here at 5. It actually bounces off at 5. And so that's okay. I hand wrote that in, so there must be one like that on your homework that threw people for a loop. Okay, here is your work. We're going to probably go over this tomorrow. but I want it done in class today, because if we do have time, you guys are my first class, so if we do have time, we will go over it today, so we can just do concept quiz tomorrow. Well, it's around 280. Oh yeah, it's 281. 281. 27 to 31. 35 to 38. 67 to 68. And 73 to 80. And if you weren't here yesterday, what'd we do? I don't have it ready.
1 through 8 and then 13 through 22.
Okay, and I checked that out off, so if you weren't here, you need to get that done too.
When did you check that out?
At the end of class yesterday?
Remember?
Didn't we go over it and I checked it
Yeah,
off?
went over it.
We did.
Okay,